Today's complex designs require a wide variety of tests to ensure quality. These complex tests can challenge your delivery schedule and stress your test conversion processes. Test for Design is a fresh approach that brings both pattern conversion and verification to the design stage long before first silicon arrives. Let's start by looking at the critical aspects of a traditional test conversion process. At the design stage, a test bench is constructed for thorough design verification. The goal is to convert it to a test set that runs efficiently on a hardware tester while matching the quality of the original test bench. During the conversion, scan, BIST, and functional tests are created. Typically, these patterns are passed on to other engineering teams that have different objectives. Eventually, patterns are converted to a tester-specific format. Once first silicon is available, the tester, patterns, and DUT are brought together. Rarely do the tests pass for the first time. Subtle errors have crept in and require painful debugging while schedules slip. But even more concerning than the schedule is the degradation in test quality. The final test may no longer have the high coverage of the original test bench. Hasty fixes to the test program end up masking test bits, creating gaping holes in coverage. The Test for Design flow utilizes a virtual test platform. Instead of passing off the test patterns to a myriad of point tools, all operations are done within a consistent database. Files are input directly from the Verilog test bench or scan ATPG. Visualization, manipulation, and merging of test files are all done within the platform. The most important aspect of the virtual test platform is thorough pattern verification. This verification is done after all pattern conversion is complete, including targeting a particular tester platform. This means you can completely eliminate the long process of debugging patterns on the tester. This will allow you to focus your efforts on the first silicon operation, knowing that your tester patterns are solid. The virtual test platform can also retarget tester-specific patterns. This enables you to leverage existing pattern sets on new designs. Just like new patterns, these existing sets can be visualized, modified, combined, and verified before first silicon. The virtual test platform executes within industry-standard verification environments. This means you can fully utilize all the debugging and coverage tools available from Synopsys VCS, Cadence Incisive Enterprise, or Mentor Graphics Questa. The accuracy of virtual test comes from detailed modeling of specific testers executing the prepared test patterns. The virtual test platform has been designed to be expandable, so additional tester models, instruments, and protocols can be added. Communication between design and test teams can be contentious when test patterns are failing. Virtual test can bridge the gap. Because it closely mimics tester execution of the patterns, the test engineer will see an output that looks similar to what is seen on the actual tester. But because virtual test is running in a standard verification environment, the design engineer will be able to look deep inside the design during pattern execution. Most pattern conversion errors can be traced back to miscommunication of information between processes. Virtual test exposes those subtle errors early. Mitigating problems after a design is committed to silicon usually results in much higher debugging costs and lower test quality. Like any other development project, correcting errors early contains costs. The virtual test environment reduces risk and makes test development schedules more predictable. You can get more detailed information, including video demos, by visiting the TSSI website.